Hi everyone, I am Dr. Peiris. In this video I am going to show you the horizontal shift of exponential functions and how to graph these horizontal shifts. So as the topics, first I'll show you the general form of the horizontal transformation of exponential functions, and then how to graph a right horizontal shift as well as a left horizontal shift. So in the previous video I explained the parent exponential function and then how to graph them. So the parent exponential function is given by this relationship f of x equals b to the x. And if there is an exponential function with the horizontal transformation, it has this form f of x equals b raised to the x plus c. So the c is basically added to x. The constant c is added to the exponent x. So that is the horizontal transformation. And the c is called the horizontal shift. And depending on the value of the c, the function would either move to the left or to the right. So if the c is greater than 0, if the c is a positive value, the function shift left by c units. If c is less than 0, the parent function shift right by c unit. So this is a little bit confusing part because we think if the c greater than 0, it might move to the right, but it is always the opposite. So something to remember, in the horizontal shift, it's basically the opposite than what we think. If the c greater than 0, shift left. If c less than 0, shift right. And since the function is moving to the left or right, there is no change in the horizontal asymptote compared to the parent function. So the horizontal asymptote is set at y equal 0 as in the parent function. Since the horizontal asymptote does not change, it is the same range as compared to the parent function, the range always stays as 0 to infinity. Now I'm going to show you a few examples of how to graph this horizontal shift. So I'm going to start with the right horizontal shift when the b greater than 1. b greater than 1 means this is 3 raised to the x minus 2. So the 3 is correspond to the value of the b. So the b is equal to 3, which is greater than 1. And now why this is a right horizontal shift? Because it says x minus 2. So the minus means we are having a right horizontal shift. So always when we do these transformations in exponential functions, it is easy if we find the coordinate first for the parent functions. So always identify what is the parent function and then obtain x and y for the parent function. Then based on that, we can easily do the transformation. Now what is the parent function? So the parent function is 3 raised to the x. So the first thing that we're going to do is to obtain the x and y points for the parent function. And I'm choosing x values as -1, 0 and 1 because it is very easy to do the calculations if we choose -1, 0 and 1. Now we go ahead and substitute values for the x, -1, 0 and 1. So the first we do the x and y for the parent function. The parent function is 3 to the x. Substitute these values and then find the corresponding y value. So 3 raised to the -1, 1/3. 3 raised to 0 is 1. 3 raised to the 1 is 3. Now we have the x and y values for the parent function. Now how do we obtain x and y values for the given function which has a horizontal shift? So this is only horizontal shift, which means no change for the y values. So the y values stay same, 1/3, 1, 3. Now what happened to the x values? This is a horizontal shift, and if it is a -2, which means this is going to be a right horizontal shift, so the entire graph need to move to the right hand side compared to the parent function. If the graph is moving to the right, which means the x values are moving to the right, so that means we must add 2 to x values. So we must add 2 to these x values because the graph is moving to the right. So minus 1 plus 2 is 1. The next one is 0 plus 2, 2. The next x1 is 1. 1 plus 2, 3. So even though this is x minus 2, but this minus 2 means the function is moving to the right, we must add 2. So that is something to remember. We must add 2 even though the function says minus 2. Now we have the points. We can draw the graph. The horizontal asymptote stays as y equal 0 because there is no vertical shift. So the points are 1 comma 1/3, 1 comma 1/3. Second one is 2 comma 1. Last one is 3 comma 3. 3 comma 3. Now we have the points, so then we connect the dots. Make sure that you don't cross the x-axis because the horizontal asymptote is at y equal 0. And the range stays at 0 to positive infinity. The range is from 0 to positive infinity. So this is how we do the horizontal shift. So all the time first find the parent function, and then depending on the shift you need to either add or subtract that value from the x values. The y values stays same. See the next example. So this is an example with b in between 0 and 1. B is half and it's x minus 1. Minus 1 means we have a right horizontal shift. First we're going to obtain the x and y for the parent function, which is y equals half to the x. Actually it's half to the x. So parent function y equals half to the x. So let's obtain the y values. Half x is negative 1, which is going to be 2. Half to the 0, which is 1. Half to the 1, half. Now since it is only horizontal shift, the y values stays same, 2, 1, half. Now what happened to the x values? It's a minus 1, which means the function is moving to the right. So we must add a 1 to these x values. First x value is minus 1. We add 1, which is 0, 0, plus 1, 1, 1, plus 1, 2. So this is minus 1, so we added the 1 because the function is moving to the right. So the horizontal asymptote is same, y equals 0. So let's put the points 0 comma 2, 0 comma 2. Next one 1 comma 1, 2 comma half. So we see that now this is a decreasing function because our b is equal to half. So decreasing function. The function is decreasing. The range is from 0 to infinity. So this is about the right horizontal shift, and we can follow the same exact method to do the left horizontal shift. This is an example of left horizontal shift with the b greater than 1. B is equal to 2, x plus 1. So the plus 1 means it is a left horizontal shift. And we obtain the x and y for the parent function, which is 2 to the x. So 2 to the negative 1, half, 2 to the 0 is 1, 2 to the 1 is 2. So again only a horizontal shift, so no change to the y values. The y values stays same for the given function. Now what happened to the x values? X plus 1, which means the function is moving to the left. That means the x values need to be moved to the left by 1. So we subtract negative 1 from these. So the x values are negative 1, 0 and 1. Now we need to subtract 1 from each x value. subtract 1 from each x. So negative 1 minus 1 is negative 2. 0 minus 1, negative 1, 1 minus 1, 0. Horizontal asymptote is same, y equal 0. So let's put the point negative 2 and half. Negative 2 half, negative 1 comma 1, and then 0 comma 2. 0 comma 2. The function goes like that. So make sure the horizontal asymptote is at y equal 0. So the range stays same, 0 to infinity. Now the last example, again a left horizontal shift with the b from 0 to 1. So the b is 1/3. So you see that it's a fraction between 0 and 1. So the parent function is 1/3 to the x. So let's obtain the parent function. 1/3 to the negative 1, which is 3. 1/3 to the 0 is 1. 1/3 to the 1 is 1/3. So no change to the y values since there is no vertical transformation. The x values is plus 2. So the x values need to move to the left by 2. So we subtract 2 from these. Negative 1, 0, 1. Subtract 2 from each. This is minus 3, minus 2, minus 1. Now we have the points, and the horizontal asymptote is y equals 0. First point minus 3, 3. Second one minus 2, 1. Last one negative 1, 1/3. So this is a decreasing function because b is less than 1. Decreasing function. The range again from 0 to infinity. The y values are starting from 0 and then go to infinity. So this is how we graph horizontal shifts. So please subscribe to my YouTube channel, Dr.Peiris Classroom, where you can find the other videos for this pre-calculus class as well as for other subjects. And visit my website drpeirisclassroom.com. Thanks for watching everyone. I'll meet you again with another video. Bye.